we say first we need to calculate W and D. Second, we need to find time. If you want, we can add also initial flux and final flux. You cannot find time until you know the initial flux value and final flux value. So the graph is already drawn. So very easy. Calculate W and D. You already know. I will not solve. W naught is equal to D plus W, and W naught x W naught dxd plus wxw. So you know all values, only unknown will be, so in this case d and w is not big problem. For case 1 where xd is varying, we need to find the w, but here w is not big problem. You can just simply apply material balance and you can get, because xd will be given. So it will be, d will be 39.13 and W will be 60.87. Okay, so let's see what we need to do is how we can solve the problem. So first part is solved. So let's see second part, how we can solve. I have multicolored pen over here. Yeah, this one. So our 96% A. So and this line is slightly up. Anyway, so 96% A, if it is correct. XD is 0.96. Okay. So how many, what is XW naught? Given 0.4. Subjected to bad distillation, bound pressure. Column has 3 trays and steel part. So N is equal to 3 plus 1, 4. Final residue XW is given 0.04. The top product contained XD is given 0.96. The data is given, V is also given 10. Oh, so what we need to do is, we don't know. So what we can try, we can just draw a random line. So what we can do is we can just draw a random line. Let's say I draw XD at 0.4. I don't know the answer. We just trial and error. And how many stages? We have 4 stages. Our goal is to find Ri. Ri means at XW naught, and RF means at XW. So we draw 4 stages. Let me take the red color. So hopefully 1, 2, 3, 4 stages. See, my guess is wrong. So what you need to do is, don't throw this data, because we need to find time. So for finding time, you need lot of data points. So what you can do is, we have to make, again like case 1, we have to make a table. So we can make XW L over V. If you like, you can write R. And then you have to write down this factor. Then we have to write down this factor for time where I wrote this one, this factor. We can write down 1 over 1 minus L over V xd minus xw square. Okay, so then we can able to find time. So what we do is, see, I draw a line, a very problem. I draw a line, the intercept is this one, so I draw a line xd and I got xw 0.21. I will record this value 0.21. L over V, I can calculate the slope. I told you the equation. What is the equation? Slope. So xd minus intercept divided by xd. So in my case 0.4. So you can see here so 0.96 minus 0.4 divided by 0.96. So I got 0.58. So I didn't discard this value. I just keep it with me because we need a lot of data points. But if you are lucky, if you are good practice, or you are lucky, you can get in first attempt, you can get the or maybe after 1 or 2. Let's say I try, guys, 2 here. I need to go back. I need to get this 0.4. So I need to little bit go back. So I move up, I will go back. So let's see. This is first stage, second stage, third stage, so you see exactly 0.4. At 0.6 I got exactly 0.4, which is our value. So 1 stage, 2 stage, 3 stage, 4, exactly. So it means this slope is given you Ri. Okay, so let's see. So I can write another value. Once we achieve this, we will feel comfortable. The second value I got 0.4, and what is the intercept? Intercept is 0.6. So let's say 0.96 minus 0.6 divided by 0.96, 0.37. You should record these values. And if you 0.375 divided by 1 minus 0.375 divided by 1 minus 0.375. So 0.6, your Ri is 0.6. This is your Ri because it is at xw naught. Now we are feel bit relaxed. So what we can do is we can do another line in between so that it look nice. We can take 0.5 because we have 0.4, we have 0.5. So at 0.5, so we got stages. So I can draw with green so I can see. So this is the first already done, second, third, fourth. So I am getting 0.2, 0.3. So I write all values at point, we're running out of time. At 0.3, also at I got 0.3, no. So we got 0.3. 0.3. So what is the slope belong to this line? We can see. So we can see the slope of this line. So intercept is 0.5. So we have, you want, you can write down also the intercept values so that if you will not be confused. So you can also write intercept values. Intercept. So here I got intercept, the first one. For this I got 0.4. Here the intercept value I got 0.6. And here I got 0.5. Then let's see what's the slope of this line. So intercept is 0.5, so 0.96 minus 0.5 divided by 0.96, 0.47, 0.479, sorry. So I got 0.479. See, good. Then we can draw another. At least we have 5 values. Okay, go another line. I will go 0.3. It looked nice, and with all the, so I can go with black so that I can see. So this line, I'll drop. Three, 4. So you see here, I got another value at 0.3. The intercept 0.3, and I got 0.1, 0.15, 0.14. So I got 0.14. But our XW value is very low. It is 0.04. So it means we need to go more down. But don't forget to record the slope. Whenever you draw a line, don't forget to record the line, the slope. So 0.3, oh sorry, 0.3, yes. 0.96 minus 0.3 divided by 0.96. So 0.68. 75. So I'm recording all values. So once you get all 5 values, then we can have, then we can draw another line. Let's say I take 0.2 and then draw 4 stages. So I use this value. Oh, sorry, this is, see, we are reaching to our goal. This is comes with 0.09. So we got 0.09. At 0.2 we got 0.09. And then we can see slope 0.2. So the slope is 0.96 minus 0.2 divided by 0.96, 0.79, 0.792. So then we can go the last, maybe hopefully you can get the answer in the last term. So let's say if I go 0.1, then we have this value. So if you feel difficult, you can just erase the line and draw a new line. So you see we are getting exactly 0.1, 0.05. So our value is 0.04. So more or less this is we got 0.05. So it will be also acceptable. You can try a little down, maybe 0.09. You will get the answer. So let's say we can take this value 0.1 and we got 0.05, and we have so 0.03, 0.05 is all acceptable. So what we have now, the intercept is 0.1, so 0.96 0.96 minus 0.1 divided by 0.96, so 0.89, 0.895, because this is at final XW. So this is your final flux. So what's equal, divided by 1 minus 0.895, so 8.5. So 8.53 is your final flux and 0.6 is your initial flux. So you can easily find the time. Then now we have to calculate all these function. I will pause over here. Let me calculate all these values. You just have to find the function. Then we can continue from here. You see, so this graph is nice. We have equally spaced all lines, and then we have all the points we cover. We have all every 0.4 we have point value, 0.3 we have value, 0.2 we have value, 0.1 we have value, below 1 we have value. So all we also have 5 values, minimum 5 values I told you, and they should be equally spaced. uh, so we have fulfill all the criteria. Now only the remaining part left is we need to find the time. So let's see how we can find the time. We need to calculate this factor. So let me calculate, then I will come back. And just let me pause.